Now I see in standard limit it is log of 1 plus x divided by x. Here in place of x it is h by x. Therefore we have to get here h by x. For that now we have the standard limit x tends to 0 sin x by x, that is equal to 1. Here we are getting sine form, but the angle is h by 2. To get the standard form, we rewrite this like this. Now sin h by h, limit h tends to 0, that is standard limit. That is why I write like this, limit h tends to 0 sin h by h into 1 by limit h tends to 0 cos of x plus h into cos x. Good morning students, welcome to btosacademy, welcome to my maths class. Already I have started differentiation in the earlier episode. Today I shall continue differentiation. First of all, finding derivatives of some standard functions or known functions. I first take algebraic functions. First of all, derivatives of these algebraic functions. First x to the power n, then log x to the base c, then e to the power x. My suggestion to students who are now reading class 11, when you follow these classes, better you take your copy and pen and start working out as I am progressing. First x to the power n, we start like this. Let y equal to fx is equal to x to the power n. Therefore, if x plus h is x plus h equal to the power n, so that f of x plus h minus fx is equal to x plus h whole to the power n minus x to the power n. First, you recall the definition of the derivative of fx, that is limit h tends to 0, numerator f of x plus h minus fx, denominator h. For that, first I take the given function as fx, also it is y, then f of x plus h, then we calculate f of x plus h minus fx and get this expression. Therefore, by definition, also it is used as using first principle. dy dx, that is f dash x is equal to limit h tends to 0 . Note one thing, you must always mention this original definition. Then you put the values. Don't forget to write this. Now we put the value. Already we have worked out limits of such types. In this case, it will be better to change the variable. For that, the denominator is expressed as the difference of x plus h and x. Put x plus h is equal to say k. Therefore, k tends to x as h tends to 0. To use the standard form, we have to change the variable like this. Therefore, f dash x is equal to limit k tends to x, k to the power n minus x to the power n by k minus x. This is quite similar to the standard limit x tends to a, x to the power n minus a to the power n divided by x minus a, that is equal to n a to the power n minus 1. Here a is x, therefore this is equal to n x to the power n minus 1. Therefore finally ddx x to the power n is equal to a into x to the power n minus 1. Next, let us find the derivative of log x. You are to follow the similar steps, just I start like this. Also, already I have discussed, this is log x, log natural logarithm, log x. In short, when base is e, we write it ln x. Then it will be now, as per the formula of logarithm, log a minus log b, that is equal to log of a by b. Therefore, this can be written as log base is e. Now I am to change this. Remember, always in the first step you write the definition of the derivative, then you put the value of f of x plus h minus fx. Better you calculate this value earlier than this. Now this is x plus h by x. If we divide, we get 1 plus h by x. That means logarithm 1 plus h by x this will be h, not x. Now I see in standard limit it is log of 1 plus x divided by x. Here in place of x it is h by x. Therefore, we have to get here h by x. For that, follow. First of all, x plus h by x. When simplified, it will be 1 plus h by x. Now the denominator is h, and here we find log of 1 plus the term that is to be made here. Therefore, I write in place of h by x into x. Now, here h is the variable. Therefore, 1 by x will be taken outside into limit h by x tends to 0. As h tends to 0, therefore h by x will also be a very small number. We can take h by x tends to 0, then now you can change the variable also like this, or you can write directly here the value 1 by x into 1, because taking h by x equal to say new symbol as k, then it will be log of within brackets 1 plus k by k, where k tends to 0. Therefore, this is same as the standard limit, and we can use that. Or you can do like this. Is equal to 1 by x into limit k tends to 0 log of 1 plus k to the base e by k, taking h by x equal to k. Therefore, k tends to 0 as h tends to 0. We can use directly this one or showing the change in variable like this, h by x equal to k, then k tends to 0 as h tends to 0. We can write the standard limit. Therefore, it will be 1 by x into 1, that is equal to 1 by x. Therefore, final step, ddx log x to the base e is equal to 1 by x. Remember, in calculus, base of the logarithm is e. If it is not e, then you have to use the logarithmic formula to take the base as e. Next, we move to third sum. Actually, you have to follow mechanically this method. Take fx equal to e to the power x, etc. and follow these steps. Just I use this format. Number 3. First, you note down those students or learner who are following this. Already I have told that you take your copy and pen and start working out as I am doing. Now, just I rub the function here fx equal to e to the power x, e to the power x plus h will be f of x plus h, then f of x plus h minus fx is e to the power x plus h minus e to the power x. Now e to the power x plus h can be written as e to the power x into e to the power h. Now you see e to the power x is the common factor. Now I put here this value, limit h tends to 0 e to the power x e to the power h minus 1 divided by h. Now here h is variable, therefore here e to the power x is constant that can be taken outside as per the law. Already this is standard limit, limit h tends to 0, e to the power h minus 1 by h, value is 1, therefore finally we get e to the power x, therefore you write finally already I have found derivatives of these three algebraic functions. Then I move to find the derivatives of few trigonometrical functions. First of all, sin x. Process will be same as discussed earlier. Let fx equal to sin x. Therefore, f of x plus h sine of x plus h. Therefore, f of x plus h minus fx is equal to sine of x plus h minus sine x. Now, this is of the form sine c minus sine d. Therefore, we use the identity to cos of c plus d by 2 into sine c minus d by 2. After simplification, it will be 2 cosine within brackets x plus h by 2 into sine h by 2. Follow the mechanical way. First take fx equal to the given function, then f of x plus h, sine of x plus h, then calculate this part and get this simplified form. Now you write, therefore, by definition, d dx sine x, you can write also f dash x, that is d dx of sine x is equal to, write the original form first, f of x plus h minus fx divided by h. Now I put the value, already I have got the value, limit h tends to 0 to cos x plus h by 2 into sine h by 2 by h. Now we have the standard limit, limit x tends to 0, sine x by x, that is equal to 1. Here we are getting sine form, but the angle is h by 2. To get the standard form, we rewrite this like this, limit, I write first h by 2. Now these 2 can be taken at the denominator of the denominator, and h tends to 0, therefore h by 2 tends to 0 into limit h tends to 0 cos of x plus h by 2. I have applied the theorem or rule of limit x tends to a fx into gx is equal to limit x tends to a fx into limit x tends to a gx. I have applied that, and as the angle of the ratio sine h by 2 is h by 2, we have to bring that angle. For that I have divided 2 h divided h by 2 at the denominator and written like this. Now this is standard limit, the value is 1 into h tends to 0, we have to put here, finally h equal to 0, therefore this will be cosine x. Therefore final step, d dx sine x is equal to cos x. d dx of sine x equal to cos x. Now students, you can calculate the derivative of cos x following the similar method, mechanical method, and you will get, I am not working out this one, it is to be done by yourself, so that you can improve your skill. Now I will work out tan x. we have found derivative of sin x, that is equal to cos x. Then if you follow the similar step, you will get number 2. I am writing the result ddx cosine x, that will be equal to minus sin x. You find yourself this one and see, the result will be minus sin x. ddx of cos x will be minus sin x. I am now going to find the derivative of tan x. For that, as the steps will be mechanically same, I have kept the other format same. In this case, it will be tan x. Therefore, f of x plus h will be tan of x plus h. Therefore, if we simplify this, it will be tan of x plus h minus tan x. Now, to use the standard limit, we have to simplify this one. How? Tan can be written as sin by cos denominator will be cos of x plus h into cos x. It will be sin of x plus h into cos x minus cos of x plus h into sin x. Now this is of the form sin a cos b minus cos a sin b. That means it is sin of x plus h minus x divided by cos of x plus h into cos x. After simplification, it will be sin h cos of x plus h into cos x. I have simplified and got this form. Then, by definition, this part will be changed. It will be limit h tends to 0 sin h cos of x plus h into cos x. Now sin h by h, limit h tends to 0, that is standard limit. That is why I write like this, limit h tends to 0 sin h by h into 1 by limit h tends to 0 cos of x plus h into cos x. The value of this one is 1 into h tends to 0. Finally, we have to put h equal to 0, and this will be 1 by cos x into cos x. Therefore, this is sec square x. Therefore, ddx of tan x will be equal to sec square x.